Hello, everyone. Hope you guys enjoy the sessions we had so far. So this is going to be the last session in this track, and we are going to talk about containers. So pardon me, I'm the one in between you and the drinks. So we are going to get started with containers. My name is Sriwantha Attanayake. I'm a partner solution architect based out of Sydney and focusing around Microsoft workloads. Um, so moving to the cloud is part of your cloud migration journey, right? Once you are in the cloud, the other step is to actually like modernize your applications once you move them into the cloud. So the containers are like a good way to do that. So let's get started. Um, you may probably like thinking, hey, I'm a traditional shop running virtual machines. Can I run my Microsoft workloads like IIS or some web services with containers? Of course, the answer is yes. Uh, Linux has been doing containers for a long time. Microsoft, with the release of Windows 2016 servers, um, made the containers. Pardon? Can't? Um, Sorry for that. So with the release of the Windows 2016 servers, Microsoft made the containers native. So what we are going to study is those who are not aware of the containers. I'm going to give a very quick introduction, a crash course into what the containers are. So if you compare a virtual machine into a container, of course, both need to have some servers to run, right? Some kind of a physical hardware. They both need to have an operating system, a host operating system to run. And in the case of virtual machines, you have a hypervisor. And on top of this hypervisor, you are running the virtual machines, right? So in this case, you have like two virtual machines. The problem with the virtual machines is that the resource sharing part is not that good. So if you, for example, in these two virtual machines, if you have Windows 2012 servers, each taking about 30 gigabyte of storage, you have 60 gigabyte of storage that they are going to consume, right? More or less, like these operating systems, like 99% of the time, the content is going to be the same, right? So, and on top of that, the virtual machines takes a lot of time to start, right? There are a lot of background processes that need to start. And these two virtual machines, we probably have the same processors running inside them, right? So there's no good sharing of resources. What it means is like in this server hardware, you are running only two applications. In the case of containers, now this is a completely different story, right? You have like an OS image, right? In this case, OS image 1. And on top of that, you have some containers running, right? So the container C1 to C4 is sharing a base operating system, right? And if it is, let's say, 30 gigabyte, you don't need to have 430 gigabyte of storage. It's simply that storage being shared across multiple containers. Of course, the container 1 and container 2 have different address spaces. They have a different file system. So if you change a file in container 1, it doesn't affect the content in the container 2, right? Same for the processors. What it means at the end is that the application packing density increases. So instead of running like 2 applications, now you can run 6 applications, right? So there are a lot of cost benefits that you can derive by having that. So that's the containers in short nutshell. Now the question is, why do we care, right? You may say, hey, Sri, we run traditional virtual machines. We are happy with that. Can you tell me a story like why we really care about the containers? Why we should take Windows containers seriously? To understand that, let's go into the story of Bob, right? So this is Bob, who used to run their traditional cloud environment in a data center, right? So he's running Microsoft workloads, and he wants to make sure that these workloads are running fine. So before moving into the cloud, he did an evaluation, right? So the evaluations that he did was, what kind of parameters that I should consider when I'm running like these virtual machines, right? Are there good customers, like famous customers running Microsoft workloads on AWS? So you have like companies like Unilever's, Coca-Cola, like KPMG running Microsoft workloads on AWS. And he also wanted to make sure, can I integrate my existing identities like Active Directory with AWS? So of course, there are different ways that you can federate identities between different environments. And so Bob is fine with that. The next question that Bob had is, are there ways that AWS innovate on Microsoft space, right? When our customer says we want to have .NET Framework exposed as all our APIs exposed on .NET Framework, we did that. They wanted to have PowerShell running on their environment, and they want to manage the AWS environment with PowerShell. Pretty much all our APIs are exposed with the PowerShell. Some customers says we have an existing license portfolio that we want to bring into AWS. And we came up with something called a dedicated host to do that. Some says we wanted to have a single pane of glass, like System Center Manager, to manage all my Windows operating systems. There's EC2 System Manager. So there's a lot of innovation happening in this. AWS is a Microsoft Gold certified partner, and the two companies innovate, and we try to bring all these technologies. Very excited to bring these technologies to you. The final question is, I have existing license portfolio, things like SQL Server. Can I bring those licenses into AWS? Yes, there are different ways you can do that. So once Bob did this evaluation back in 2016, he did the evaluation and moved to the cloud on 2017, and he's a happy customer on 2018 now. But when he go to his infrastructure, this is what he found, right? His servers are utilized, the CPU utilization is about 20% of the time, right? Sometimes it peaked to about 40%. So Bob is now in the cloud, he can do some cool things. So instead of us using, for example, a 4x large instance, he quickly changing to X large instance. The CPU utilization of 4x large was about 15%, so it increased to about 60%. You still have about 40% headroom if there's a spiky workload. And immediately he saves about 75%, right? But the question is, so this is changing of the instance size, pretty obvious one. Are there different ways that you can increase the server utilization is the next question, right? So the containers allows you to do that. I'll come to that part later. So Bob has another concern, right? Right now he's running on-demand instances. So it's M4 4x large instance he's running. It cost him about $2,500 roughly per month. And if he goes for reserved instances, right, he immediately saves about 35%, right? The other thing Bob can do is, hey, I'm on a three-year reserved instance. I'm going to bring my existing Windows Server license into AWS. And he's going to use something called a dedicated host, right? So a dedicated host is kind of like a special hardware dedicated for you. And pretty much all the, you have like multiple slots available for you, right? So in both these cases, the problem Bob has is, I'm going for a reserved capacity reservation. I'm going for a dedicated host with multiple slots. The question is, can I use all these capacities that I'm reserving? If the Bob can be confident that he has enough workload that he can pack in these reserved instance, he can make sure that he's not worried about going for these reserved instances or dedicated host. So if Bob can pack as many applications as possible into that, that's what he wants to do. The other case is the web services. So he has 4 web applications, 50% utilized, database 25% utilized, altogether 5 servers. If it cost him about $1,200, right? If Bob can go into one big M4 4x large instance, pack all the websites and database into one, he can get the utilization up to 75%, right? Saves immediately about 33%. But the question here is, can I isolate these environments? The HR doesn't want to interfere with the finance web application. Database administrator, when he's patching the environment, he doesn't want to interfere with the websites running. But if there's a way that we can isolate these environments, Bob can go for one big server, pack everything into one, increase the server utilization, and get these savings. So far, what we found. To savings, you need to go for reserved kind of instance. Right sizing is the answer. You need to increase the server utilization. To get the headache-free IT, I need to find easy methods to deploy and to easy patching. And the way to do that one is the proper isolation. So those who are, I'm going to give an example and then showcase your demo. So this is a control M application. So this is used to like manage large number of batch jobs. So for example, in the previous company that I worked for, there were like thousands of batch jobs that were scheduled using this tool, right? The challenge with this kind of a tool is job scheduling. So imagine that you have a job one that starts, a nightly job that starts at 1 a.m., finish around 4 a.m. Job 2 starts somewhere in the middle. And then you have job 3 that depends on job 2 that starts somewhere around 7 a.m. Once in a while, there's these bad guys appear. So instead of, let's say, using 10% of the CPU, it will use 100%. So what will happen is that job 2 will get delayed, and it will create some challenges for the job 3 to schedule. But with the aid of containers, you can isolate these different batch jobs and then allocate just enough resources for them to like run on the environment. So what I'm going to do now is to go for a demo, showcase you how you can isolate that environments, just allocate the hardware that you wanted to have. So I'm in my I have this batch application. It's a normal exe application. And so when you are running it, it just print out some numbers, right? Spin up some multiple threads, and it's like consuming a lot of CPU in this case, right? So when this application is running, it uses 100% of the CPU, a classic bad behaving application, right? So what I want to do is to control like how much CPU that this is going to use, right? To do that, what I'm going to do is to package this application inside a container, right? So Docker is based on something called Docker images. So what I'm going to do is to use a Microsoft Windows Server core image, right? And then package this bad behaving application inside that, right? So what I'm going to do is to run Docker in this case, right? I'm going to call Docker run. I'm going to call it interactively so that I can see what the content of this container is. I'm going to mount a folder called ctemp binary where I have this bad behaving application inside the container called cinstall. And I'm going to run this Docker image called Microsoft Windows Server Core. So inside the container, I'm going to run PowerShell, right? So when I'm running this command, from the time that I press enter, it goes inside the container, right? So you can see that the container starts very quickly. So now we are inside a container. So this is a complete new environment. It has its own file system, own process structure, completely isolated from rest of the containers and the host, right? To give you an idea like how completely isolated these environments are, consider the file system. So if I type the dir, you can find that the folder structure inside the container is completely different from the container structure you find in my host. If you start another container, it will have its own file structure. This is how you get the isolation that you wanted to have. So this is the isolation in the file system. So all the registries are different, installed programs are different. If I look at the process list, you can find that it has only few processors. That's why the container starts very quickly. Whereas if you look at the virtual machine, which this one is running, you can find that there are a lot of processors. And it consumes memory, it consumes a lot of resources, right? So this is why, and these processors are completely different set of processors compared to what you find on the another container. So what I'm going to do now is to package that bad behaving exe application inside my container, right? So I'm going to copy that exe application into a folder called my app. So this is the install is the mount folder. So I copy that bad behaving application inside the container. And just to check whether it works, I'm going to type run this my batch application. The only difference here is that now this my batch application is running inside a container, right? So of course it works fine. So what I'm going to do is, so I tested that it's working fine inside the container. I'm going to exit from this container and then create an image out of this a newly installed application, right? So the exited container is called 3DFC, so that's containers are identified with some numbers. I'm going to save that change I made after copying the exe application. So I call docker commit, and I'm going to save my changes into a new container image called my company batch app, right? So in this case, what you find is, so I create a new image out of that application that I packaged, right? So if I go to Docker images, you can find that new application that is packaged as a Docker image in my image list. So it didn't take a long time to create that image, right? So far, so good. So the next thing I'm going to do is to run Docker, but instead of allocating all the resources of the CPU, I'm going to allocate only 20% of the CPU, right? So I say CPU percent, I give 20%, right? And in this case, I'm going to run my company batch application, right? That's the image that I just created. And I'm going to run my exe application inside this container, right? So what you can find here is that when I run this, so instead of, so my batch.exe, so instead of like taking, so when I press enter, it will start the container. So instead of using all the container resources, you can find that it's actually like choking, like trying to get some CPU, right? You can find that the CPU percentage, the utilization is now about, roughly about 20%, right? And that's how the containers allow you to slice the hardware into small pieces, right? So you can have like multiple of these batch applications sharing the same one with proper isolation. So let's go into the demo or the presentation again. So you saw like how to like slice your hardware into small pieces, right? Using containers with proper isolation. So next thing is how I can manage these images. So in this case, I have like two applications, application 1 and application 2. Application 1 may first depends on a base operating system like Windows Server Core, right? So it's about 30 gigabyte. And then you have another, you may do some security patching on top of that. You have a layer 2. And then you may install another framework on top of that. You have another layer called layer 3, let's say .NET framework. And then you have application layer 4 where you install the application. Application 2 also wants to use that patched version of the operating system, right? So it starts depending on the layer 2. It may be a Java application, install the Java framework in layer 3, and then application in the layer 4. So the beauty here is that there's a sharing of layers in Docker containers, which means that the storage footprint is less, which means that the patching also is going to be less, and downloading and uploading these images is going to less because you are only going to get the delta changes, right? So there are shared layers in this concept of shared layers in Docker. So what you find is that it can download, for example, only the delta changes after a security patch, right? So we have this. So what it means for you is to actually, it allows you to patch your environments very easily, right? So I have like two applications here that depends on ASP.NET latest image. When a new security patch comes, Microsoft update that. You just change the version into a new one. And then what you find here is that the version 20 comes, the application keeps working very fine, right? And in the case of Windows Server, it's also easy. I have version 200. From the time that I go for the new update, it can easily like upgrade itself, right? So far what we found is managing one single container, right? Managing one container is very easy, right? But what happens when you start packing as many containers as possible in your hardware available? That's where the challenge comes in, right? So you need to manage how they are going scheduled, whether you have enough resources in these servers. And that's where the Amazon ECS or Elastic Container Service comes into picture, right? ECR or Elastic Container Registry is where you keep your saved images. So it's something similar to Docker Hub, only difference is it's kind of a private repository, so you can apply the security that you want to have, right? So how ECS or Elastic Container Service works is that you have this concept called a cluster, right? A cluster is nothing more than an abstraction over an existing set of EC2 instances, right? So one of these instances may be a SQL server already running on a Windows environment, right? Or it may be a complete new EC2 instance that you spin up, right? You can add and remove instance as and when you want. So you create something called a task, right? Task consists of things like what kind of containers I want to run. So maybe you have a HR application that has a SQL Server backend and a web application. What kind of constraints I want to have? For example, the HR application don't want to run in the same machine the finance is running. Maybe the HR application wants to have a bigger instance size, right? Maybe it wants to run in a different region, right? So you can define constraints. The other thing is what kind of resource that it wants. So HR application probably wants to have, let's say, 4 GB of RAM, right? So once you define this task, you create something called a service, right? A service is nothing more than wrap around that. It tells things like how many tasks, how many of these containers I want to run. What's the deployment strategy, right? So if I'm publishing a new version of this HR application, how I'm going to decommission the existing versions. And then things like how I'm going to auto scale. So when the workload comes, when the CPU goes to 80%, I want to add more tasks into this. And ECS has some built-in intelligence, so it can do things like how to place these containers on different machines available, right? So you may have a situation like, for example, the bin packing. So it fills one existing server with the available containers, and it goes for the next one. Or it can do another orchestration like, for example, a balance spread, where it plays one by one into 2 different instances, right? So ECS has these kind of orchestration features built into that, which allows you to do place these containers in your infrastructure. So what will happen is that you create multiple services, one service for HR application, one for finance, one for your batch application, and you place them on the cluster, right? And it will run nicely, and it knows how to auto scale, and if one instance fails, you can start another instance, and these services will get placed on different instances. So moving to the cloud is only part of the journey, right? You need to have efficiency, agility, automation. So Bob wants all these things, right? The question is, can you do these things with his preferred tools, his preferred Microsoft tools, with using containers? So there are different ways you can do that. To give an idea, I'm going to showcase you an example. So the Bob has a running website, web application, backed by 2 containers, right? Version 1 of that application is running. So he got a new requirement to update this application. He hired a developer. He's running Visual Studio. He's going to create this application within Microsoft Visual Studio. He made the changes and published that one into TFS, right? Team Foundation. So it's a Microsoft Source Repository Control, or virtual VSTS, or so these are like all Microsoft built tools that he's going to use. So when he commits those changes into the source control system, it starts a build agent, builds the software, test it, run all the unit tests, run some security checks, and then once the build agent finishes it, builds the image and publish into ECR. So once it publishes into ECR, or the Elastic Container Registry, it tells the ECS, hey ECS, I created a new image, that's a new version of the application, go and orchestrate that in the cluster. So ECS will start a new version of that application in the cluster, and then will update the containers to the version 2. And the load balancer will direct the traffic to the new version and slowly decommission the old version of the application. And finally, you will get the version 2 of the application running, right? So that's about the CICD pipeline. Let's go into understand for a demo to see like how it works. So I have here my Lula Pets web application. So it's a simple web application, right? ASP.NET application. It keeps tracks of the owner of the pet, how many steps the pet took. So this is like my cat, it's a flat cat. It's not exercising a lot, only 475 steps. So if you go into the information page of this web application, you can find that it's backed by 2 containers. So the container IDs are printed here. So there are 2 containers doing round-robin load balancing for this. Right? That's why this ID changes when you refresh the page. Right now, I'm running application version 1. Right? So if I go into my load balancer, you can find that there are 2 containers running on the same instance with 2 different port numbers, and they are both healthy. Right? So these are the 2 containers backing that web application. If I go into my ECS cluster that hosts these containers, I have 2 clusters. One is called Win3. So in the Win3, I have 2 services, Lula website and batch application. Right? So these are the services I talk about. So in the case of this Lula website, I have set the number of tasks to 2, and the desired count is 2, and the running count is 2. So it's a healthy state. I'm running 2 of these containers. Right? If I go into deployments, this is the last deployment I did to the cluster. You can find that desired count is 2, running count is 2. And if I go into my TFS, so this is the build system. So the build system is Microsoft tool, TFS system, where I'm going to control my source control and do the build, right? So here I have created one build definition for my Lula Pet 1. So here you can find my previous builds, right? Successful builds. If I go into the edit button, you can find that different build steps that I have defined. So in these steps, get source, I'm going to download all the Git repository content. I'm getting all the NuGet dependencies in the next step. In the third step, I'm building the solution, right? So it's using the MS build solution to do that. And in the next step, I'm using PowerShell, right? AWS has PowerShell API. So I'm going to publish this image into the ECR using PowerShell, right? And in the final step, instead of using PowerShell, I'm going to use command line, and I'm going to call update, tell the ECS, hey, I created a new image, go there and then publish into the container cluster once you are done. So I go to the build steps. So this is how I have defined my build steps. The next thing I'm going to do is to act as a developer. So, sorry. So this is the developer. So right now, the application is version 1, right? The old version. So I got a new requirement to change the application. So I change it from version 1 to version 2, right? And so this is a new requirements. I added new features, just simulating a change in a web page. So after I did these changes, I'm going to save this one into the source control system, right? So what I'm going to do now is to go to my, so this is Visual Studio, all Microsoft tools. I'm going to save the change I made into my repository. So I say commit. I give it some kind of a comment. Hey, I added new features that you wanted to have. So what I'm going to do is to automate this process so that there's no any operational person involved in deploying this application to the infrastructure. From the time I save it and commit it, it will start a new build behind the scene. Application is still version 1. It's working fine, no issue. But behind the scene, the build system is automatically building the change that I made. So it got the dependencies. So this is the build system building behind the scene. It building the Visual Studio solution. It's going to create some images, a Docker image. So let's create the image. And it's now publishing this image into Elastic Container Registry. So you can find only the Delta changes are being uploaded to the container registry. And then it publish it, and then it's called ECS to deploy this application. So back in the cluster, you can find that a new deployment has started, right? So you can find that here there are 2 deployments running at the moment. There's an active version already, the old version, and the primary, which is the new version. So slowly, this running count of the new version comes to 2. So right now, its running count is 1. And application is still version 1. So if you ask why the new version is being deployed, the application is still version 1. The reason is the application haven't passed through the health checks. So once the new application desired count equals the required count, and the load balancer do the health checks of the application, right? So this version 1 will change into version 2. So if you look at this load balancer, you can find that it has started 2 containers, right? So you have the red in the new containers and the 2 old containers, right? So new containers are in the initial stage, and right now it's serving, so one of these new container will come healthy, right? So you can find that some of the containers become healthy. Now if I refresh this application version 1 will change into version 2, right? It takes some time because anyway the IIS needs to start the process. So behind the scene, the users in fact don't experience a downtime when you are running it because the load balancer nicely direct the traffic, right? So so in a few moments you can find that the application changed into version 2 and it added the new feature, right? So new version is now healthy, old version is draining. It will slowly decommission these old containers that it has provisioned. So I still have the old containers running. If you keep refreshing this cluster, you will find that the ECS will automatically go there and then remove the old version gradually. So the running count becomes 1 instead of 2. And if you keep refreshing, it will become 0, and then the old version will slowly decommission, taking away the resources it used. So we go into our, so what we learn here is different things. We go into the slide deck. So what we learned so far. So we learned about containers, like why it really matters to use the containers, right? There are different cost-saving scenarios that are applicable for the containers. You can isolate the resources using the containers, right? There are different ways that you can bring Windows containers, package your application, exe application, website using containers. You learn how to isolate your environments. Containers, one container has its own file system, own process system, and isolation is some cool thing that containers provide. And finally, we learned about automation, right? Being in the cloud, part of the journey is actually to automate your deployment, make the software engineers more productive, and put operational people into more value-added services. So hope you enjoy this session. I'm very happy to do this presentation, and that's it. Thank you.